So in the last video we talked about just a basic introduction to the unit circle and how we could come up with the angles going around the unit circle, the common angles in radians. And in this video what I'm going to take you through is finding the sine and cosine values of those angles. We're actually going to take a look back at what you learned in your geometry class, and I want you to think about a triangle like this. And let's suppose we have the hypotenuse to be 1, and then right here we have a 30-degree angle and a 61 right there. If I told you this side was 1/2, I want you to pause the video and find the value of x here, this third side. So how could you go about doing that? And I want you to leave it, you can actually just make sure you leave it as a fraction. Let's put it that way. Don't find it as a decimal, and don't use your calculator, find it as a decimal and then turn it into a fraction, because those don't always work out like we want it to. See if you can do it without a calculator. So pause the video and do that. And if you pause the video and did it, you can say, hey, for some people they might try to mess with trig on this. Some may already know what the sine and cosine values for 30 and 60 degrees are, and that's fine if you do that. But if you didn't, you could use the old Pythagorean theorem, where you have a squared plus b squared equals c squared. And so if we call this side A, this side B, remember this side over here by itself, the hypotenuse is always C there. And so it goes in by itself, so it's going to be 1 squared is equal to x squared plus 1/2 squared. So you get x squared plus 1/4 equals 1, or x squared is equal to, what do we got here, 3/4. And then square root both sides. So x equals the square root of 3/4. Or you could say that's the same thing as the square root of 3 over the square root of 4, which equals the square root of 3 over 2. You say, well, isn't there a negative root? There is, but remember x is a distance, and we can't have a negative distance, so it must be the positive root we're taking there. So in this case, we get square root of 3 over 2. Let's look at another one. Suppose we have another right triangle, and this time we're going to deal with a 45-degree angle here. And once again, I'm going to let the hypotenuse be 1. Now, with this one, I want you to find the side length right here, x. Pause the video and work that out. Alright, so I take it that you pause the video and you try this out. And this one you say, well, can I still do Pythagorean theorem here? And the answer is yes, you can, because we know that if this is 90 and this is 45, well, we learned in geometry that all three angles add up to 180. So you can say 180 minus 90 minus 45 means this angle must also be 45. And if two angles in a triangle are equal, well, the sides across from them must also be equal. So if this side right here is x and it's across from the 45, the side across from the 45 right here must also be x. And now you can do Pythagorean theorem and say, well, x squared plus x squared must equal the hypotenuse squared. And so this gives me 2x squared equals 1, or x squared is equal to 1/2. And then you're going to square root both sides, and you get 1 over the square root of 2. And if you rationalize that denominator by multiplying by square root of 2 over square root of 2, you get square root of 2 over 2. That equals your x. Now you might say, why do I care about, showing you all this? Weren't we talking about the unit circle? We are. But this kind of sets us up with a couple of things that we can come up with. For instance, if I asked you, what is the sine of 30? What's that equal to? Sine of 30 degrees. Well, you can look at this and say, well, here's my 30-degree angle. This is the opposite side of that. across from the 90 is our hypotenuse, and the only one left here is the adjacent side. And some people use SOHCAHTOA when they learn this right triangle trigonometry. I always like to tell my students, Oscar had a heap of apples, like this. Oscar had a heap of apples. And then they have their sine, cosine, and tangent equaling that. So whatever guide you want to use, I don't care. Most times students kind of stick with the one that they learn, and then they go with that. And so if you say, okay, I've got the sine of 30. I know that sine is equal to opposite over hypotenuse. This is the opposite side. And then this is the hypotenuse. That would give me opposite over hypotenuse, which reduces to 1/2. You could say, what's the cosine of 30? You say, well, cosine, that equals adjacent over hypotenuse. The adjacent right here, we found out what the adjacent was. It was square root of 3 over 2. So you put that square root of 3 over 2 over the hypotenuse, and you get square root of 3 over 2. You could find the tangent of 30. We know the tangent is opposite over adjacent. Opposite is 1/2. Adjacent is square root of 3 over 2. It's a fraction over a fraction. We're going to keep the first, switch to multiplication, and flip the next one. And we get 1 over the square root of 3, which ends up being square root of 3 over 3 when you rationalize that denominator. So the tangent of 30 is square root of 3 over 3. We could do it with a 60-degree angle up here. Sine, cosine, and tangent of those values. You can do it with a 45-degree angle over here. If we say the sine of 45 degrees is equal to the opposite, if we circle that 45 right here, the opposite over the hypotenuse, I get the square root of 2 over 2 divided by 1, which equals square root of 2 over 2. And so this is just kind of a review of the right triangle trigonometry you already know, a little bit of Pythagorean theorem, but notice we're using these common angles that we talked about yesterday on the unit circle. They're just in degrees. We talked more about radians, so let's look at a little bit about the unit circle here. Here's one. I know it was in here somewhere. And so this currently I've got it divided up so that we've got our 90-degree angle, our 180, and then our 45-degree angle is marked out in there. But we're not going to talk about it in degrees. We're going to talk about it in radians, so we get used to doing that. So writing this out in radians, we say this initial spot right here is 0 radians. If I go all the way around the circle, it would be 2 pi radians. Halfway to 2 pi is pi radians. Halfway to pi is pi over 2. And halfway to pi over 2 is pi over 4. And then remember from here we can count around the circle and go, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is what? 3 pi over 2. 6 pi over 4 reduces to 3 pi over 2. And then 7 pi over 4. And then our 8 pi over 4, which is 2 pi. So that's just kind of a quick one. I would suggest watching that video and getting practice on the long run of it, but I don't want to spend too much time on that since we did that yesterday. Now, the reason why I went through the beginning of this video, our 45, 45, 90s, or same thing as our pi over 4, pi over 4, pi over 2s, is to get you used to that particular right triangle. In fact, if I make a triangle right here, and let's suppose I just shade it in with something. Let's see. I don't know. Let's do a crayon here. So if I look at this triangle right here, we call it the unit circle because the radius is length 1. doesn't really have a specific unit to it like feet or yards or anything like that, but it's a radius of 1. And so let's write that in there. This thing has a radius of 1. And if I write it right here, notice the hypotenuse of this right triangle is 1. Just like we saw on the page before it, wherever it is, we have a hypotenuse of 1. The angle is 45 degrees, or pi over 4. That's what I'm dealing with right here, pi over 4. Or 45 degrees, however you want to think of it right now, but we're gonna lean more towards radians, and eventually you'll prefer radians as we do this work, because you'll get so used to it. And so when I ask you what are the lengths of these sides, you can start to say, wait a minute, I've seen something like this before. I know from this work over here, it's going to end up being the square root of 2 over 2. In fact, you can punch it in your calculator. Go ahead and do that now. Take the square root of 2 and divide it by 2 and see what you get. So do that right now in your calculators. It should be a decimal. See what it is. So when I punched it on mine, I got 0.707. So let's look back at our graph here. And if we think about the radius being 1, meaning from here to here is length 1. Somewhere in here is about 1/2. Somewhere in here is about 3/4. And so notice that the side length of this triangle is about 0.707. Somewhere around in there, because that's about 0.75 or 3/4. That's 1 whole. Right here is 1/2, so it's more than 1/2, less than a whole, a little bit less than 3/4 of a whole. And so that should make sense that square root of 2 over 2, if you think about it as a decimal, 0.7, that's about the length of this side right here. Likewise, for the vertical run here on this thing, it's about the same as well. Well, it is the same. If this length right here is 1 whole, and this would be half of that, or 0.5, notice this isn't quite 0.5. If I were to draw a dashed line going from here to here, it's more than 1/2 of a whole. And so dragging this out, there's a whole, there's a half, right around in there's about 3/4. So it makes sense that's about 0.7 as well. And so our side lengths of our triangles are, we'll put it down as 0.707 and 0.707. But, you know, that's not the complete length, so I don't like doing that. I like to leave the exact value. The exact value is the square root of 2 over 2. So this side is square root of 2 over 2. This side is square root of 2 over 2. And so from there, we can figure out the sine, cosine, and tangent of it. The sine of pi over 4 is equal to the opposite side over the hypotenuse. What's the square root of 2 over 2 divided by 1? Oh, it's the square root of 2 over 2. So it becomes a nice thing because this length right here, the length of that side of the triangle is also the sine of that side of that angle down here. And so this isn't always the case with triangles. You could have a triangle, say like this, where this is, I don't know, we'll go ahead and make it, let's make it 45 again. Here, let me restart this triangle here, drawn. Let's get the triangle tool here. There we go. That looks a little bit better when I let the computer draw it, doesn't it? So if this were pi over 4, and say the hypotenuse was 5. It's a right triangle. Well, what's the sine of this pi over 4 right here? Well, it'd be the opposite side over the hypotenuse. But since this hypotenuse is 5 times as big, and it's a similar triangle to this one right here, then the side length right here would also be 5 times as big, or 5 square roots of 2 over 2. And so now when you take the sine of that, it's going to be the opposite over the hypotenuse. So 5 square roots of 2 over 2, divided by 5, make this denominator a fraction, and we're going to keep the numerator. switch to multiplication here and flip this guy, you get 1 over 5. The 5's will cancel. Multiplying straight across, you get square root of 2 over 2. So it doesn't matter what that hypotenuse length is, pi over 4, the sine of it's always going to be square root of 2 over 2. The convenience with the unit circle here is the hypotenuse is 1. And so we don't have to do, not that this is complicated math, but we don't have to do all these steps. We know that the opposite side divided by the hypotenuse, well, it's the opposite side divided by 1. So you just end up with this opposite side here is the sine of that angle. Now if you think about the cosine of that angle, the cosine of pi over 4, you got the similar thing because cosine is adjacent over hypotenuse. Well, if you're letting the hypotenuse be 1, then the cosine is the equivalent to just the adjacent side. So the cosine of pi over 4 is just square root of 2 over 2 also. And so now we've got this triangle right here, and we know its side lengths, and we can quickly find out the sine and cosine values of it. So that's the real reason why I started you off with this triangle right here, so you could become familiar, like, hey, if I know I got a 45, 45, 90, I know the sides are going to be square root of 2 over 2. If you don't have that memorized, I'm not a real big fan of memorize, memorize, memorize. You should know the Pythagorean theorem. You should be able to work these steps right here to figure out that it is the square root of 2 over 2 on both of these sides right here. So, how does that help you? Why are we putting it in the unit circle? That sort of thing. Well, let's look at this triangle right here and see where else it shows up in the unit circle. So, here I've got the unit circle again with our 45, where our pi over 4 angle is marked out. And so this is the triangle we started off with. We had the sine, cosine values of those, the square root of 2 over 2. And so notice this triangle shows up in other places. If I were to move this triangle, and let's see if we can spin this to make it work a little bit better, and place it right here, I land at 3 pi over 4. Now, we talked about coterminal angles and angles in standard position. 3 pi over 4 is not this angle right here. 3 pi over 4 is actually, if you were to take and draw a ray, let's make it, I don't know, a different color here. Let's go with, I don't know, yellow. Yellow may not be good, but here's our ray. Here's our initial side. It's actually a rotation going around to right here. That's what 3 pi over 4 is. Or in other words, if we were to just draw it like this, it goes from here to here. This angle is pi over 4. It's what we call the reference angle. The reference angle is the smaller angle between this horizontal line drawn and our terminal side. So the reference angle is still pi over 4, and so we can use that same triangle in here. The actual sine and cosine values of 3 pi over 4 are going to be very similar to pi over 4, using the same triangle there because of the reference angle. So let's take a look and see what we get here. And so remember, we're in quadrant 2, and this triangle is the same as the one we dealt with over here in quadrant 1, with one exception here. Notice it's flipped over the y-axis. If you look at this green dot or the center of the circle as the origin, you can kind of look at it like that. Then we're in quadrant 2, and then this value right here, our x value going to the left, would be negative. So this is still square root of 2 over 2, that's side length, but the direction the triangle is facing right here is going to be the negative direction for this side of the triangle. Now, on the y-axis, though, we're still in the positive zone over here, so this is going to be a positive square root of 2 over 2. And so now, when we look at the reference angle and say this is our pi over 4, or you could say it's the same thing as saying what's the sine and cosine of 3 pi over 4. Let's write that out. The sine of 3 pi over 4 is equal to the opposite over the hypotenuse. So it's going to be square root of 2 over 2. What's the cosine of 3 pi over 4? What's going to be the adjacent side over the hypotenuse, or negative square root of 2 over 2. And so now we have our sine and cosine values there. So let's back this up now and go back to our triangle here. My undo button's broken. I'll just go to the eraser. Sometimes this program gets a little glitchy when I start to record a bunch on it. Computers can only handle so much, right? And I'm going to have to color back in this. Sorry about this. It's taking up a little bit of time, your time, but it just looks better colored in, right? And so moving this triangle around, we can actually spin it around again. Let's see, how do I want to make it this time? Right here. And so this is talking about the angle 5 pi over 4. Oh, I'm still in crayon mode. So 5 pi over 4 starts, initial side always right there, and it ends right there. So that's what we're talking about. It's using the same triangle, so I know that the side lengths are still square root of 2 over 2 and square root of 2 over 2. However, if we think about it in terms of x and y axis and the origin, in reference to the origin here, I actually, traveling from the origin, have to go a negative direction on the x-axis, so it's negative square root of 2 over 2. And then from the y-axis down, I have to go negative square root of 2 over 2 down to get to this point right here. And so once again, to find out what are the sine, cosine, and, well, we're not going to talk about tangent today, but the sine and cosine values of this, I'm going to do the same thing. I know that the hypotenuse is 1. The opposite side is negative square root of 2 over 2. So I can say that the sine of 5 pi over 4 is equal to the negative square root of 2. Look like that. Negative square root of 2 over 2, like that. Over 1, but dividing by 1, we've already discussed that, doesn't do much for us. Same thing with cosine. The cosine of 5 pi over 4 is going to be the adjacent over the hypotenuse. The adjacent side is negative square root of 2 over 2. Divided by the hypotenuse just gives us negative square root of 2 over 2. All right. So one more time, let's look at 7 pi over 4. What would happen with 7 pi over 4? I'm just going to duplicate this. It's easier than erasing everything. Let's see, what do they call it? Clone on this one. And let's just spin this thing around. Where does it fit in? Right there. It's the same triangle. And once again, I've got square root of 2 over 2. Square root of 2 over 2 is the lengths of the sides of the triangle. Let's drag those over and put them in right here. And this time, I'm not talking about that angle. We're talking about the angle that actually starts right here on the initial side and goes all the way around the terminating side right here. That's 7 pi over 4. Has the same reference angle, so we use the same triangles. Now keep in mind, on the x-axis this is positive, so the square root of 2 over 2 can be positive right there. That's what we want. But going down like this is going to make this value negative. And so our sine of 7 pi over 4, here's 7 pi over 4, we're actually just talking about this angle right here, the reference angle. The opposite side is negative square root of 2 over 2. So it's going to be the negative square root of 2 over 2 over the hypotenuse. Once again, the hypotenuse is 1, and so that's our sine. The cosine is going to be this length, the adjacent side. So the cosine of 7 pi over 4 is a positive square root of 2 over 2. And so notice these angles are larger than 90 degrees. When we talked about right triangle trigonometry, we had to keep everything acute. But now we can talk about angles larger than 90 degrees, larger than 180. You can talk about a 0. You know, what's the sine of 0? And the sine of 90. Those things we're going to talk about in a moment. Right now, I've only discussed these 4 right here for a reason. Okay? So I want you to open up your worksheet I gave you yesterday, where you're filling out the unit circle with the radians, and notice they have some ordered pairs there. So we can start to use this to fill out those ordered pairs. So ultimately, what I want you to be able to do in this class is I can just say, what is the sine of 3 pi over 4? And you just spit it out to me. What's the cosine of 5 pi over 4? Let me know what it is. What's the tangent of 7 pi over 4? And you should just be able to recall them like if I were to asking you, what's 3 times 5? And we're going to do some games where you can show me like, hey, I know how to do this in my head without drawing out a unit circle, and just become super comfortable with doing all these things. And the best way to do it is to know, well, first off, with these pi over 4 angles, know your triangle and visualize that triangle. So this is our blue triangle right here. I want you to visualize when I say pi over 4, that triangle. I want you to visualize when I say what's 3 pi over 4, I want you to visualize the triangle like that. At 7 pi over 4, you should be able to visualize the triangle down here in this quadrant looking at it like that. And of course, 5 pi over 4, the same thing. If I can get to flip around the right way. There it is. You should be able to visualize that triangle. And you should know the triangle, after doing this a bunch, is square root of 2 over 2, square root of 2 over 2. And the hypotenuse is 1, but really the square root of 2 over 2 and square root of 2 over 2 is what you're thinking about. Know that sometimes they're positive, sometimes they're negative. Well, that's not good. So it can be a little funny sometimes. Nope, it wants to break up. Let's make sure these are still grouped. There we go. So anyway, as you go to draw these out, these ordered pairs, think of it like this. You're drawing it just like if I had to say graph the point 3, 5. How would you graph that? You'd say go over 3, up 5. But instead, you're graphing this triangle right here for your ordered pair. You're saying, I go over how much? I go over square root of 2 over 2. And it's in the positive direction on the x-axis. How much do I go up? I go up a positive square root of 2 over 2. And when I visualize the triangle, why does it keep doing that? It keeps splitting them up. That's why the video is so long. It's because I have to keep correcting a software issue. If I had a better program, I'd use it. But so far, this one does me pretty well for the most part. Maybe it's the crayon part messing it up. It's meant for elementary applications, probably. There we go. Now visualizing this triangle, I don't know why I'm even trying with that triangle thing anymore. If I were teaching it in class, I usually have big poster board triangles I put up on the board, but if you're watching this, you're not in my class right now, or you're at home watching it or something. This one right here, if we're talking about graphing this point up here, where is it? Well, from the origin, I go to the left a square root of 2 over 2 amount, but it's in the negative direction, so I put negative there. And then I go up square root of 2 over 2. So we're going to go up square root of 2 over 2, and that's in the positive direction. If I'm talking about this triangle down here, I'm not going to try to move that one because it keeps messing up on me. Once again, I'm going to go to the left a negative square root of 2 over 2, and then I'm going down a negative square root of 2 over 2. Put that negative on the outside there. And that's where that point is. If I move this triangle down here, look, I can shade it in like this, right? That looks just as good. I'm going to the right a positive square root of 2 over 2. And so that's the x-coordinate, square root of 2 over 2. And I'm going down a negative square root of 2 over 2 units. That's your y-coordinate. Now compare these x and y coordinates with what we got on the previous slide, taught finding the sine, cosine, and tangents of each one. And you should notice something. You should notice that the sine value for this is right here, your y value. Your sine value right here is your y value. Your sine value for this angle, 5 pi over 4, is your y value. Highlight you, y value. It's not going to let me highlight, but you get what I'm saying. It's the y value. And then your sine value right here is your y value. So y value, and I'm I'm going to make them all red. Let's see here. Your y value is your sine value. If you look at the x value, what is it? I'm going to draw it in a different color. It's going to be green, but it is your cosine value. Oh my goodness, I've got too much going on here, huh? Unit circles get crowded pretty fast. I'm trying to draw. Okay. Fix this real fast. So right here, and this is our x value, that's your cosine value. X value right here, that's your cosine value over in here. Cosine value down here as well. And so, all that to be said, sorry I get a little distracted there with the computer. I'm going to continue if I keep selecting crayon. Our x value is going to be our cosine value because on all of these it's the adjacent side right here. And then our sine value is going to be our y value. And so for these 4 points we figured out, those are our sine and cosine values. Alright, now for our next one, we've got to look at our 30 degree or multiples of 30 degrees going around the unit circle. So I want you to practice what we talked about in the last video. I want you to mark these out in radians. I'm actually going to get rid of our pi over 4, our multiples of pi over 4, so we can just focus on one thing at a time here. So there are the blue lines. I'm going to get rid of those. So pause the video and mark out all the angles that are listed here. See how much you remember from the last video. So the way I like to do it is say this is our 0. All the way around the circle would give us 2 pi. Halfway to 2 pi gives us pi. Halfway to pi gives us pi over 2. Now, I'm not going to do halfway to pi over 2 because that would give me pi over 4 and it's not marked here. But notice these are broken up into thirds. So 1/3 of pi over 2 is pi over 6. And now each one of these sections is a multiple of pi over 6. Just like if you're talking about degrees, it's a multiple of 30 degrees there. So we can count by pi over 6. That's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6, which is 2 pi. Now don't leave them like that. I expect you to be able to reduce them, but I try not to reduce them until after I'm done with this. That way I know I can quickly see 1, 2, 3, 4, 5, 6, 7 all the way around the circle there. So now go through and reduce those. So there they are all reduced, so you can check and see if you reduce those well. Remember we said 30 degrees is the equivalent of pi over 6. So in the beginning when we did our 30, 60, 90 triangle here, we're actually doing a pi over 6, that's the equivalent of 30, pi over 3, and instead of 90, a pi over 2 right there. So what did we come up with our side values? We said this is 1. And can you remember what this side was? I'll give you a hint. Don't look. Look over here. This is the same triangle. Let's actually just drag this one over in here. Does that? Don't do that. That's the same triangle right here, right? Because that's our pi over 6 angle. So if I want to know how tall this is, if this is length 1, just give an estimate. Just kind of draw your dashed line over like we did on the last one and say, where does that look like it lines up at? It's about 1/2. And that is the value of that side there. So this is 1/2. And if you need to, do the Pythagorean theorem from here, or you might already have it memorized or remember it from what we did in the beginning. It's the square root of 3 over 2 right there. Now, just like we did in the last one, square root of 2 over 2, type in your calculator, what is the square root of 3 divided by 2? So when I did on mine, I got 0.866, which is really close to 0.9. If you didn't get that, maybe you did this. Maybe you said square root of 3 divided by 2. What you're really doing there is taking the square root of 3 halves, which is 1.22. Don't do that. We're actually going to say, what's the square root of 3? Hit enter, and then divide by 2, and it gives you the 0.86. So looking at this right here, 0.86, well, that looks pretty close to 9/10 of the way to 1 whole on the radius there. So that should make sense too. This is about halfway up on the y-axis, and this is about 9/10 of the way to 1, 0 on the x-axis there. Either way, though, I don't want 0.86, I don't want 0.9, I want the square root of 3 over 2 right here for this length. So I showed you in the last one, the pi over 4 angles, how I want you to visualize that triangle, where it's 1 and then square root of 2 over 2 and square root of 2 over 2. Sometimes you got positive values, sometimes you have negative values, and that's okay. Just know where they are. What I've done here is I've taken this triangle and just copied and pasted it and kind of maybe spun them around or flipped them to match up with these 4 angles. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Notice the y values on all of them have an absolute value of 1/2. Alright, but really, the positive negatives do matter here. So let's go through and just mark out our y values real quickly. Our y value right here is going to be a positive 1/2 because we're above the x-axis. So I get the y value to be positive 1/2. Same thing on the left side here. Y value, positive 1/2 because we're above the x-axis. Over here, though, the y value is negative. So it's going to be negative 1/2. Same thing over here. Y value is negative. It's going to be negative 1/2. And then I know the long side of this triangle is the square root of 3 over 2. So over here, this is the x value is positive square root of 3 over 2, and then the y value is positive 1/2. So square root of 3 over 2. That's my ordered pair for this point. To the right, square root of 3 over 2, up positive 1/2. Over here, my x value is negative, so it's going to be negative square root of 3 over 2. Negative square root of 3 over 2. And this one is positive square root of 3 over 2. And there are those 4 angles. Now remember what these mean. This is the opposite side. Whoops. This is the opposite side to this angle. So opposite over hypotenuse is the sine. This is the adjacent side to this triangle. So, or that in reference to this angle. The adjacent over the hypotenuse is the cosine. And so it's still following the same thing as we did on the last page. The x value is your cosine, the y value is your sine. And so now I can say, what is the sine of 11 pi over 6? And I want you to think, hey, 11 pi over 6 in your head is almost 12 pi over 6, which is 2 pi. So we're just pi over 6 short of 2 pi. So you should be visualizing this triangle right here. And then, I think I said the sine. The sine is going to be that short side there, which is 1/2, but it's going to be negative. So the sine of 11 pi over 6 is negative 1/2. So we're going to do lots of practice with this in class, and we'll get you to where you can come up with any of these angles, sine, cosine, tangent, and even the reciprocal ratios as we get to talk about those. Now, the other red lines on this page follow the same triangle, but what happens to that triangle, let's get one of those available here. Let's actually spin it so that it's sitting up on its side like this. And I'm actually going to match it with the one in quadrant 1. Not like that. Thank you for hanging out with me if you're still here. I said left, right, right? No. What do we want to do? Up, down. Let's do flip up, down. And then I'll eventually get it there. How about like this, and then flip up, down. Oh my goodness. I'm going to pause the video and get this thing set up. Okay, good thing I paused the video. It took me 3 hours to figure that out. I promise you it's the same triangle as these over here. I just didn't want to bore you with my... Actually, maybe it humors you to find all my failed attempts of trying to get that transformation complete. Anyway, notice this triangle matches up right there with our pi over 3 angle. And so it has the same side lengths as the other four I've got drawn on here, but now the x value has changed. It's now the one that's going to be 1/2. So our cosines on these are going to be some form of 1/2 or negative 1/2. And so I'm going to clear up these old triangles and draw in the new ones for you. Alright, so all I've done here was take this triangle and duplicate it 4 times and put it in here. And so once again we're going to write out ordered pairs here and look at my x values. For these two triangles, it's going to be 1/2. Here's 1/2, and then I got to put in a y value. Same thing over here. Go over 1/2 and then down some y value. In both cases, x is positive because I'm to the right of the y-axis. Over here, my x value is also 1/2, but I'm to the left of the y-axis, so my ordered pair is going to be negative 1/2. Negative 1/2 down here as well because I'm going to the left, negative 1/2, and then down. Now, the long side of the triangle we know is square root of 3 over 2. So I'm going to go up square root of 3 over 2. That's a positive because I went up. Here I'm going left, negative 1/2, up square root of 3 over 2. Over here I'm going negative 1/2 to the left, and then I'm going down negative square root of 3 over 2. Same thing here, my y value is negative, so this is going to be a negative square root of 3 over 2. Remember, I'm writing this out as square root of 3 with a negative in front, not under the radical. Like that. There's a difference. One's imaginary and one's real here. So, those are my sine and cosine values. 4 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So notice what we've done today. We've come up with, we have some, on the previous page, we did the ones for pi over 4, 3 pi over 5 pi over 4, and 7 pi over 4. This page, we did them for these, 8 angles right here. So far, total, we've done 12 angles, the sine and the cosine for 12 angles. But we're still missing 4 that we haven't talked about. So let's do one more, and this will be real fast, of those 4. So here are the 4 angles that we haven't discussed yet, and all I want are what are the ordered pairs of these 4 points. Well, if our radius is 1, I go over 1 and up none. Over 1, up none. Once again, right here, if our radius is 1, I go left or right, none. So my x-coordinate is 0. My y-coordinate is up 1. If I make my x-coordinate negative 1, my y-coordinate becomes 0. And then right here, I'm going 0, comma, negative 1. So what's this allow me to do? It allows me to say I know that the sine value is my y value. So the sine of 0 is 0. The sine of 2 pi is also 0. Boy, I know it's a long video when I can hear you cry while you watch it. That's some futuristic stuff there. But anyway, you could also look at any of these really and say I know that the sine of 3 pi over 2 is negative 1. The cosine of 3 pi over 2 is 0, because remember our x-coordinate is going to be our cosine, y-coordinate is going to be our sine. So what's this mean for you? You should be able to look at that worksheet I handed out with the unit circles on it, and you should be able to tell me the sine, cosine of any angle on there, You should be able to write out any angle in degrees or in radians. And then I'm going to give you unit circle quizzes on these. Now, they're not going to be your unit circle quizzes you may have had in the past where you had to do the whole unit circle and write it all out. And really, that's a big pain to grade. And you're not going to be in calculus and well, as far as I know, any of the teachers I know, they're not going to say today's quiz is on the unit circle. They might as a review. But what you will need to know is you will need to say, what is the sine of 3 pi over 2? And so you should be able to look at this and say, hey, I've got the sine of 3 pi over 2. That's right here, 3 pi over 2. And the sine is my y value. So that's -1. I should be able to say, okay, what's the cosine of 5 pi over 4? And so you have to identify where is 5 pi over 4 on the unit circle. Well, I know 4 pi over 4 is at pi. And so 5 pi over 4 is just 1 pi over 4 past it. And so this is our triangle that we're visualizing. It's the one that is square root of 2 over 2, square root of 2 over 2, but this one's going to be negative. But cosine is our x value. This is negative also. So this right here is our cosine. It's going to be negative square root of 2 over 2. The practice quiz I'm going to give you today is a good indication of what I expect you to do in under like 2 minutes. It's going to be like 10 of these type of questions. No calculator, 10 of them, no notes, no unit circle. I want you to practice that out. We're going to do a ton of practice in class, and I'll probably do it in my future videos also, just some pop, not really quizzes, but just some pop questions to challenge yourself. And you can challenge yourself also. All you can do is look at any of the common angles on the unit circle and say, what is the sine of that? What is the cosine of that? And check it. And the cool thing is, you can actually put in your calculator, what is the cosine of 5 pi over 4? And it will give you the equivalent of negative square root of 2 over 2, like negative 0.707 or something like that. So thanks for watching with me. If you stay through all 48 minutes of this, awesome job. Hopefully I didn't bore you out too much and that you learned a bunch and you know it in depth. But give those other things a try. Don't just memorize the unit circle. Don't do little tricks with your hands or whatever else they teach you in other classes or on YouTube, whatever else you watch. If you have to memorize it, if you're one of those people, then that's fine. I think you're going to get so much more out of it if you look for patterns and you understand these triangles. If you can start to visualize these triangles going around the unit circle, it's going to help you out so much more. All right? Thanks for watching, and let me know if you have any questions.